Good morning, everybody. Let's begin the presentation of my course project. My team name is Clean Air. The topic of my presentation is going to be development of an ANN-based air pollution predicting system. My team is only me, and that's my student ID. The problem statement of my project can be devised as follows. We first build an air pollution ANN model that can predict the AQI index. Then we finish the training and testing process of this ANN model. To do this, we first classify our data into test training data and then the testing data and the validation dataset. And finally, we check the performance of this model. So the outline of this presentation is going to be as follows. First is the introduction. Second, the problem statement. Then comes the explanation of data set. Firstly, we will take into consideration where did we get this data from, the components of this data, and how the AQI, that is the air quality index, is measured. The measurement of this AQI is going to be based on a formula. Further, we will have a model. As we are using the artificial neural network for our model, we are going to be using Keras. In this presentation, you will also understand how the training, the testing of the dataset is done, the checking of the accuracy, then the accuracy plot, and then also with the model loss plot. And then comes the conclusion. To get this data set, we went on the website epa.government slash the as you can see, the EPA is an environmental protection agency. So our database is coming from this environmental. If you want the link to this dataset, you can just see it above. Now, the air quality index. The AQI values are measured by the amount where it or the categories it would fall into. And to devise these categories from good to hazardous, there have been different set of colors to plot the graph or how good the air quality is. So if the air quality is good, it's generally given it's generally given in green color with the values 0 to 50. If it's moderate, it's given from 51 to 100. If it is unhealthy for sensitive groups, it is from 101 to 150, which will be given in orange color. Then comes the unhealthy air quality, which is 151 to 200. Then comes the very unhealthy, which will be from 201 to 300. And then comes the worst air quality that can there be, which we can call as the hazardous level of major health concern, which will be from about 301 to 500. The color we are using for this is going to be maroon. Now, this table is used all over the world globally by EPA agency. So this is a standard. Now the data set. We convert the data set to use into our model into .csv file. As you can see, the, the measurements and the components of our AQI has all the following categories of different pollutants in the air. It not only has the main pollutant, but it will also show you what the overall AQI on this day at this area, which is given by the site name, as you can see from the fourth column, that is the D column. The first column is the date, the second column is the overall AQI, the third column is the main pollutant, the fourth column is the site name, and finally you get to see all the constituents of the air. Now, this data set has all these values from the year 2001 until the year 2018. So, we have a vast amount of data that will be used in our training model and then the testing model. So, the data set from our Excel is gonna be converted to a .csv dataset file. It will look as follows. When we got the data, you can see that there were a lot of missing values. Now, these missing values, we needed to always make sure that our model wasn't getting affected by these missing values. So to work on it, we had to take an average value. Finally, let's see how we built the model using Keras. First, we import all our libraries. Then we use the TensorFlow. First, we need to build up the environment for our model. And for that, we need to import all the libraries. Then we need to give the source for our CSV file. Then we need to make a processing function. Our processing function will look as follows. Now, from the table that we saw, the standard table which has the color border and the values for the AQI, we need to build up our model based upon that. So our process function will have the following following line. Our model simply uses the dense network and has the activation function, which is the ReLU function. The learning rate that we use in our model is 0.0001. When we compile this model, we use the loss function binary cross entropy. We also use the optimizer, which is the Adam optimizer. Our loss function is sparse categorical cross entropy. Now, the type of our model that we are using is 797. These are the total parameters that are going to be in the testing data, the trainable parameters and the non-trainable parameters. We always want the model to not undergo fitting. That is why we have some parameters which are untrained. Those parameters are going to be 640. After the data undergoes training, we check that the accuracy is 99.57. We also do the same with our testing data. Our testing accuracy is 99.01. Finally, we see how we can plot the graph for our accuracy and the loss functions. To plot the accuracy, we import the library and as follows. This is how you can see how our model accuracy is and how the model loss is. In our training dataset, we see that the model accuracy is gradually increasing. So, yeah, with this, we come to the conclusion that that is how we can develop an AQI model that can predict the air quality index. Thank you so much. In this slide, you can see the predictions of our AQI model. Now, this shows air, which component of the air was the most polluted. Thank you.